Hello, my name is Carlos Negron, and this presentation is a summary of the experimental examination of pollinator-mediated selection in a sexually deceptive orchid for my critical analysis of scientific research at the University of Florida. Pollinator-mediated selection is the mechanism by which pollinators decide which flowers to pollinate or not to pollinate. Angiosperms, which possess phenotypes pollinators desire, are more likely to engage in pseudocopulation. Some phenotypical characteristics may induce pseudocopulations. Some angiosperms engage in sexual deception by mimicking the appearance of a female pollinator. Today, research being performed on the sexually deceptive orchid Shiloglottis trapeciformis shows that while pollinator attraction is governed by pollinator preferences, the efficiency of pollen transfer is governed by how well the pollinators can mechanically fit on the flower and interact with the labellum effectively. Attraction to sexually deceptive orchids is influenced largely by odor. Morphological traits are hypothesized to play a role in the mechanical. Although past research shows that sexual deception is a major contributor to pollinator attraction, it is unclear what role morphological features play. Researchers hypothesize that variation in flower morphology within and among Shiloglottis species is under stronger pollinator-mediated selection for mechanical fit than for actual female mimicry or sexual deception. In other words, they expect that the pollinator is responsible for stabilizing selection of morphological features such as the labellum size. In an effort to determine what sort of morphological features pollinators preferred, researchers designed the following experiment. They collected fresh virgin Shiloglottis specimens and introduced them to a new population of pollinators. In addition, the labellum of the orchids were cut in different lengths in order to observe the effect of pollinator-mediated stabilization selection by recording the interactions of the pollinators with the orchids, exhibiting different morphologies. In order to perform this experiment, the orchids had to be introduced to a new pollinator population in order to ensure sufficient pollinator activity for experimentation and avoid low visitations from learned avoidance by pollinators. Regardless, there was a rapid decline in the response to the experimentally presented flowers and a very low incidence of pollinators carrying the orchid pollen. The orientation in which the pollinators landed on the orchid showed to be important in pollen transfer. Researchers observed that pollinators which interacted with the labellum in a forward orientation rather than a backward orientation were significantly more likely to successfully harbor pollen. Data collected from pollinator visitations to flowers with varied morphologies showed that there was no difference in the amount of pseudocopulations at control and experimental flowers. This indicates that flower manipulation did not affect pollinator attraction. However, the flowers with the shortened labellum did not provide a good mechanical fit for the pollinators in the forward orientation, so they were less likely to engage in pseudocopulation. Furthermore, the duration of pseudocopulation was shortened in the experimental flowers, suggesting that stabilizing selection preferred the control flowers. From this experiment, researchers found that sexually deceived pollinators exhibit varied behavior around flowers, and the largest factor contributing to pollination was pseudocopulation. This analysis of the data is logical, seeing as there is only a 13% chance of successfully achieving pollen transfer. In order for flowers to successfully pollinate, they must be visited by multiple pollinators. The length of pseudocopulation was reduced significantly in the manipulated flowers, which suggests that stabilizing selection is likely playing a role in pollinator selection. It is critical that we understand what components influence pollen transfer so we can determine which plants are most fit. Once having determined which plants are most fit, we can help influence evolutionary pathways. Selection analysis alone cannot determine if pollinators are acting as vectors for selection. Future research should be done in larger sample sizes, and experiments should focus more on naturally occurring phenotypes than on experimentally manipulated morphologies.